All right, continuing on our notes for section 10.2, we're going to focus here on the last objective for this section, which is to use the formula for the sum of the first n terms of an arithmetic sequence. So there's a famous story about the mathematician Gauss, and he was asked this question to find the sum of the first 100 natural numbers, is what they're called, without using a calculator. So I'm going to give you guys a moment to see if you can think of a strategy of how you might go about doing this. So as the story goes, Gauss was 10 years old when he was posed this question, and within a minute, he brought the answer up to the teacher. And the teacher was just so surprised that he was able to come up with something so elegantly, so quickly. So his strategy was, maybe it's similar to what you might have come up with, to add the first term and the last term. So in this case, 1 and 100. And we get 101 when we add those together. And then he added 2 plus 99 and also got 101, 3 plus 98 and got 101. And he thought, well, I'll just continue to do that and make pairings until I get those middle two pairs and get 101. So what he thought then is, well, I know I'm going to get 101. And because I'm using the numbers from 1 to 100, I'm going to be making 50 pairs that are all going to sum up to 101, giving him 5,050 is the sum of that set. Okay, so we're going to use his idea to understand how we do that with other arithmetic sequences. Okay, so the formula for finding the sum S sub n, okay, now sum here, we use the capital S here to stand for sum. The n stands for the number of terms that we're adding within a sequence. So if I wrote like S sub 10, I want you to find the sum of the first 10 terms of a sequence. And the formula looks like this. So it's the number of terms in the sequence divided by 2, because what you're doing is the same thing Gauss did when he came up with the 50. If you have the numbers from 1 to 100, that means there's going to be 50 pairs. So there you're taking how many terms in the sequence divided by 2 because you're pairing them up. And you're multiplying that by the sum of whatever the first term was, plus a sub n, which is whatever the last term in that is. So if you're finding the sum of the first 10, that last term would be a sub 10. In our case, it was a sub 100 because you're adding up those 100 numbers. Okay, a sub 1 here stands for the first term, and a sub n here stands for the nth term. Now keep in mind this formula holds if you have an arithmetic sequence. Okay, which is all we're dealing with right now, but eventually we'll have other kinds of sequences that we look at sums for. Okay, so we're going to find the sum of the first 27 terms of the arithmetic sequence 3, 6, 9, 12, and so on. Okay, so I'm going to use capital S to notate. I'm finding the sum, 27, to notate that I'm indicating I'm finding the sum of the first 27 terms of that sequence. It's going to look like this, 27 divided by 2. That's for pairing them up. Then I'm going to take the first term, I'll just write it as a sub 1 right now, plus a sub 27. Okay, so formula-wise, I can continue that on so that I would get 27 over 2 times a sub 1, and I know what that is, that's 3. Oops, I don't know why I put a comma there. Plus, but now I get stuck because in this particular sequence, I don't have the 27th term. So I've got to go find that using a formula. Now we are dealing with an arithmetic sequence. So in an arithmetic sequence, the most common way for me to write a formula for the nth term of a sequence, if that's arithmetic, is the common difference times n minus 1 plus a sub 1. So for this, I want to find the 27th term of that sequence. The common difference here is 3, because we're adding 3 each time to go from one term to the next. N minus 1 will be 27 minus 1 plus a sub 1, which is 3. So it means I'm going to start with the number 3, and I'm going to add 3 to it 26 times to get the 27th term of the sequence, which ends up being 81. So 81 is my 27th term. Again, we, on the last video, kind of developed that formula, and that's not the only formula that works, but that one's the most common. So then just finishing that out, getting that arithmetic done, we get 1,134 is the sum of the first 27 terms in that sequence. All right, for example 4, this question is write a formula for the general term, the nth term. So they want me to write an a sub n formula. That's what they're asking me for. Of the arithmetic sequence whose second term, a sub 2, is 4, and whose sixth term, a sub 6, is 16. All right, so we'll get back to the formula part in a second, but we're missing the first term. We know that the second term is 4. We don't know the third term. We don't know the fourth term. We don't know the fifth term, but we know the sixth term is 16. So a sub 1, 2, 3, 4, 5, 6. One of the things we're going to have to find here is the common difference. Now, one of the things you can remember is that the common difference is the same as a slope. And this, since it's the second term, would correspond to the 0.24. And this, since it's the sixth term, would correspond to the 0.616. And so the common difference would be the same as finding the slope between those 2 points. Because it's arithmetic and linear, we're going to get 16 minus 4 divided by 6 minus 2, which is 12 over 4, which is 3. 3 seems to be our common difference number today. Now, my most common formula to write this is going to be d times n minus 1 plus a sub 1. And you can use that and you can go back and find the first term. It's not going to be particularly hard to do, but we can also adjust that formula. Because I don't know the first term, just use the ones you already have. The second term is 4, so I could do my common difference. Since it's the second term, I can do n minus 2 plus the second term, which is 4. So that's one option. I could also have used the sixth term is 16, so I could do n minus 6 plus 16. That works too. But you have lots of options for how you want to do that. You could go back and find what the first term is. Not particularly hard once you know the common difference is 3. That means this one has to be 1. So you could use that first formula and use a 1 there for that a sub 1 slot. So that's the end of this set of notes.